Okay, what we're doing today is something called slope fields, and those are, if you look at this picture down at the bottom, this is an example of what a slope field looks like. It looks like all these little lines, and it's just a representation of a graph. And so we're going to look at that, and there are certain skills that you have to learn and that you'll be responsible for. And one of those things is for you to draw a slope field. So if they ask you to draw one, they will give you a derivative. They'll always give you a dy dx. So notice dy dx equals negative 3x. So ultimately you have to get little lines on each of those dots. And you're probably thinking, oh my gosh, that'll take forever. Well, we're going to see if we're going to make it a little bit easier. So let's look. So the slope of the function is dependent on x. So let's just put in, let's let x be equal to 0. Let's say, what would dy dx be if x is equal to 0? Well, according to this formula, negative 3 times 0 would still be 0. So when x is 0, let's just look at this point right here. Is an x 0 there? The slope would be 0. Now let's draw a line, a little line, where that has a slope of 0. And you say, well, that'd be a horizontal line. So I'm going to just draw a horizontal, small little horizontal line. It's kind of hard to get it right on the dot with this thing. Right through there. Now, again, I said when x equals 0, isn't it true that this point is 0, comma 1? Isn't x also 0 there? So I actually know that all of these are going to have a slope of 0, so I draw that horizontal line. So what's cool is, what makes your timing a little faster, if dy dx only contains x's, then on the slope field, what will be the same? The columns. Because think about it, your slope isn't dependent on the y's, so the columns will be the same. If I had a dy dx that just had y's in it, then that means a change in x won't matter, so the rows would be the same. So now I just can do it very, very quickly. Now let's just plug in some more things. If x is equal to 1, so I'm talking about this column right here. If x is equal to 1, my slope would be negative 3. So some people set up a chart. You can do this however you like. Again, they don't grade your work, they grade your picture, so you set up whatever you prefer. So if I put in 1, my slope is negative 3. Let's plug in 2, and that slope would be negative 6, and 3, that would be negative 9. So let's look at how we're going to do this, because what they grade is, for 1, these slopes are all negative. As I go out this way, I just got to get steeper, because a slope of negative 3, then it's going to get steeper and steeper. So I'm going to kind of do this one about maybe, gosh, it's hard to do it with this thing, like this, and I'm trying to make these all the same. And actually on the dot, it's harder than it looks with this recording thing. But then I've got to go a little steeper, and I try to match those all the same. And then I go a little bit steeper. Now I know it looks like this 9. It's like, gosh, how can I tell if those are vertical or not? Well, here's the deal. Write this in your notes, if dy dx is undefined, then you actually leave blank. You do not fill out a line. So if a line is drawn, it may look vertical, but it's not vertical. It's very, very steep, but it's not vertical. Well, what about here? We have x equals negative 1. So when x is negative 1, that slope would be 3, and of course 6 and 9. So instead of slanting negatively, on the left side they're going to be positive, and I try to match. I kind of try to look at this column and this column as the same, just one positive and one negative. And then I'm going to go steeper. So I try to match this one and this one. So hopefully I'm doing that sort of. Those kind of look the same to me. Make that a little steeper here. Let's try to go like that. There we go. I try to match. And then here I make almost vertical. And I'm trying to match that. So you could do it a little better with paper and pencil, but you get the idea. And that's what a slope field is. So it's not that it's certainly not hard to do. It's a little tedious to do, but you just figure out the slope, and it's kind of a comparison. Are you going flatter when you need to, or steeper? Are the positives and negatives right, etc. Now, what's going on is that you can probably kind of see a shape kind of taking form. And I mean, if your eyes just kind of look at that, you probably see a quadratic. And doesn't that make sense? Because what would have a slope, a derivative of negative 3x would be, in fact, a quadratic. So let's look at another one. Actually, I know I'm kind of going sporadic on, well, no, I'll go back. I'll go in order. Okay, it says the slope field of the differential equation. So again, that derivative is given. Do you notice how all the columns are the same? Because your slope only has x's in it, so that should make sense. It says find the particular solution to this differential equation with the initial condition y of 0 is 1 and sketch the solution curve that passes through your point. Okay, well the first thing I want to do, I actually want to sketch the solution curve. On the AP test, they'll have actually a point drawn. So let's say this is the point 0, 1. What that means is you're going to, again, you kind of look at this and people say connect the lines. Well, you don't necessarily connect them, but the slope of your function has got to kind of match what's around it. So it gets flat there, and then I get steep, steep, and steep. You need to make sure you go to the edge there of the, I've got a little box that I can't move, but go to the edge of your slope field, and then this way I'd come here, and then my function kind of gets flat because I have a minimum, and then I get steep, steep, steep going this way. So it kind of looks like that. And that would be, if it says sketch a solution curve, that's what it would look like. Now, obviously, depending on the point that they give you, the solution curve would look a little different, and we'll practice that on the back as well. If it says to solve this differential equation, it's what we've done this before. What do we do when we have dy dx equals negative x squared plus 2? Okay, remember we're going to separate. I'm then going to integrate both sides. So that would give me y equals negative 1/3 x cubed plus 2x plus c. You make sure that you put that constant of integration right there. And as we've talked before, this is called the general solution. But they told you a specific point. So when they do that, if I put in zeros for my x's, I should get out 1 for y. And so that would be, c would be 1. And so I would get the final equation of y equals negative 1/3 x cubed plus 2x plus 1. And I get this right here. Friends, these two things match. This is the equation to that graph I just drew. And this thing right here is called the particular solution, the one. There's thousands and thousands of equations that have that derivative. This is the only one that goes through that point. All right, so let's look at some more things. So here's what I want you to do. We're going to do a couple things on the back. I want you, it says, what would dy dx look like? Does it have x only, y only, both, or constant? So ignore those dots for now. Look at these four graphs, and I want you to label, using what we talked about before, let's pick out the constant one. Let's think of what dy dx would look like if it has a constant like 4. Well, what would that look like? That means it's not dependent on x or y. So if it's constant, then the rows and the columns, you're going to have the same slope everywhere at every single point. So which one is that? Well, obviously, that's going to be this guy. Okay. Now, which one is going to have x only? Well, we said if it has x only, what's going to be the same? The columns. So looking at the three that are left, which one has the columns that are the same? So this one is going to have x only. If the rows are the same, it's going to have y only. And if neither the x's or y's are the same, then you're going to have both. So this, if the rows and the constants are all different, you're going to have both. Now, another skill that you're going to have to do is going to be able to pick out an equation. So now that we have this, friends, you're never going to have to come up with these equations like on free response. It's going to be a multiple choice where you have to pick them out. So I'm going to give you choices for each of these, and I want you to circle which one it would be. Do you think? Okay. Give you 3 choices on this last one. Okay, so I want you to go through and pick which one you think. Well, let's start with the constant one because that's the easiest one. Is the slope of those lines, if my choices are 5 and -5, well, which one does it have to be? Well, you go this one because those slopes are slanting this way, so they would be negative. Okay? Now, the other thing that helps me, like if I'm deciding between these, the things I look at several things. A couple things that help, I look at my zeros, I look at my horizontal tangents, and if it has blanks, okay, so in other words, I look for my zeros and I look for my blanks. That's when the derivative would be undefined, right? So the derivative, this is dy dx equals 0, and dy dx is undefined. A lot of times that helps me, because if I'm choosing between these, this line right here, that looks like, again, you're going to be able to read numbers a lot better on the AP test and my test, but that's at -2. Okay, so which one of those, if when I plug in -2 for y, I get 0, well, which one does it have to be? It has to be this one. Okay. I'm going to go down to this guy. With this one, I look at my zeros and my undefineds. Notice when y equals 0, I get a dy dx of 0. However, do you see how I don't have any lines along when x equals 0, then dy dx is undefined? Well, if that's true, then that means I can eliminate that answer choice. So I'm down to both of these. So on both of those, if y was 0, I'd get 0 for dy dx. And if x is 0, I would get undefined. So how do I pick which one it is? The last thing I kind of look at is I get in my quadrants and check points until I can eliminate one. Okay, in other words, positive and negative. So I get in a quadrant. Okay, I pick a point. So let's just pick a point over here. If I picked a point in quadrant, and that was just random. I could have done quadrant 1, 2, 3, 4. I mean, I guess until I can eliminate. So if I picked a point, let's say the point -1, I'll do it over here, -1, 2. I think we'd all agree that that would be a point in quadrant 2. So if I plugged in to this guy right here, dy dx would be 2 over -1. So that's -2. Is that slanting the right way? That's negative. So I go, okay, let's look at this one. That one looks pretty good, but I'm going to double check. If I'm down to these two, what would dy dx be if I said this was the answer? I would change the value of y and -1, and that would be 2, so I should be slanting positively if that were the answer. So I know that's not right, and this is going to be the correct one. So I just pick points and kind of guess at it until I find a discrepancy and I can eliminate one. The last one is, again, you can do a couple things with this one. First of all, you can notice that they're always positive, so that would kind of clue you in. But make sure you understand, y'all, there's a difference when they ask you for dy dx versus when they ask you for y, because your eyes, I know if you look at this, you see like a cubic. So a lot of times people pick this right here. No, if you're going on what your eyes see, that's y equals. So the y equals is a cubic, which means the derivative is going to be an x squared. Okay? Now, the last thing is on this first one, notice there are 2 dots. I want us to practice drawing the solution curve for those, through those 2 dots. So I want you to practice drawing those solution curves through that top point and that bottom point. So I'll give you a second or stop the video and then you do that. So what would that look like? Well, this guy, I just kind of follow. Again, your graph should match the slope. Oop, I'm not doing so good on that one. It should match the slope of those points. So it's doing that and then it's kind of flattening. Notice that would be the solution curve. Again, I put arrows on it. I go to the edge. I do not cross an asymptote. Okay? What you draw is the largest continuous. You have to draw a continuous thing. So if it was asking for the solution curve through that point, that is all I would draw. If they gave me the point down below, what would that one look like? Well, I kind of would draw there. I'd put my arrow, and then this guy would come. That one's not too great. Kind of a little more slopey. And then I would get horizontal there. So again, you draw kind of the largest continuous piece that you possibly can. Okay, so let's practice this one, because this is how it's going to be. Y'all, the art of elimination is a definite skill when it comes to slope fields. Okay, again, you're never going to have to come up with these numbers on your own. You're like, oh my gosh, how'd they get those numbers? You don't have to worry about that. Process of elimination. So I'm going to give you a second to figure out what you think those 3 are, and then I'll tell you how I'll do it. Well, when I look at my answers, this is the one that I would do first, personally, because this both has y's only and so does this. So I go, okay, this is the only kind of odd man out. So I'm looking for the one, if it has X and Y, if it has Y's only, we know that the rows are going to be the same because a change in X won't matter. So this one, the rows are the same. This one, they're going to be all not the same. So I look for the one that the rows, that one, the rows are the same. As I go across, my eyes are looking across, going, yep, those are all the same. These, same, same, same. My rows are the same. So this guy, I know this one has to be B, because if you look at my rows as I go across, well, those, golly goodness, those aren't the same. Okay, neither are my columns. So it has X and Y, so my rows and my columns are different, so I know that one has to be B. Then I go to the next one. I go, okay, I know the rows are the same. After that, I go to the simpler one. That one, I could do anything, but this guy, I would do him second. That's just easier. Now, what I would notice, remember, I think of the positives and the negatives. This is a positive number. So that means if I plug in a y that is positive, dy dx would need to be positive, right? So above the x-axis, right, when y's are positive, my lines better be sloping positively. If I put in a y that is negative, then my slope is going to be negative, so my lines down here have to be doing this. Correct? Okay. Well, so which one follows that? This one does. Sorry, I was looking at this. This one does, so my answer is, sorry, the C goes with this. So that's going to be C, because if you look in A, do you see how up here, above the x-axis, I have some negative ones? Well, that can't be this one. So that would have to then be that guy. So that's how you work it. Process of elimination. So let's talk about the what you're responsible for. Okay? The skills that you're responsible for is, one, you have to draw a slope field. You're going to draw, you're going to make a chart, you're going to think about what would kind of make it faster and do things, and it's a comparative game. Make sure you have your positives and negatives. Is it getting steeper, flatter, etc. You also would be responsible for drawing a solution curve through a particular point and finding its particular solution using differential equations, and we'll be doing that a lot the next couple days as well. And then finally, you would have to be able to pick out, kind of like we did here. Will you be able to pick out a dy dx from multiple choice and being able to get it? If they ask you for y, remember y is what your eyes see. Like this is y equals x squared, x cubed rather. And that's something that you could figure out. What would y be here? What do your eyes see when you look at this? You see a line. So that would be like y equals negative 5x. So it's a line that's slanted that way. So if they ask you for y, it's like, what does your eye see? And that's your equation. All right, so work on that slope fields and you are good to go. Peace out.